Well, we can start. We are live now.
Okay, thank you. Yeah, please. Can you start formally?
Sir, your audio slightly less, sir.
Yeah, it's all right. I'll take care.
Yeah. Thank you, sir. We can start, sir.
Good afternoon. Shall I start, or you have to start it?
No, sir. You can start.
Okay. Thank you. We are, let me say, very good afternoon to all. We have four presenters in this session on best operating practices in pulp and paper mills. Basically, this is the real studies, actual studies they will be presenting, and they are from the leading paper manufacturers. Like we have from JK Paper Mill, then we have from Yash Pakka Limited, APPM, and TNPL. So just to start, yesterday we had the inaugural session, and sustainability was the key word. And this is what we have to think about, we have to talk about, and we have to work about the sustainability. In a wider sense, we can say this is the capacity of the Earth's biosphere and human civilization to coexist. But as a paper manufacturer, it is our responsibility to maintain the production at a certain rate or level by avoiding the depletion of natural resources in order to maintain an ecological balance. So the natural resources we use are the fuel, the water, and so many other things which we are using. So this is our responsibility, moral responsibility, as well as we have to have a social responsibility also towards the society. So today, I hope our presenters, they will focus on the sustainability issues, and I thank them for being with us today. So first of all, I would like to invite Mr. Surya Narayana Palaparthi. He is the Chief Manager, Technology Development from JK Paper Mills, and he'll be speaking on best practices on resource efficiency. So, Mr. Surya Narayana, please introduce yourself, and you can start your presentation, please. And the time we will maintain a strict time of 15 minutes for each speaker. Please, Mr. Surya Narayana, the stage is yours.
Thank you, sir. I'll start sharing the presentation. Tapliyal sir, please confirm whether my screen is visible. Hello? Hello?
Yes, sir. Your screen is up, sir.
Okay. So I'm starting. I'm Surya Narayana. On behalf of JKPM, I welcome you all for this presentation. I sincerely thank CII and IPMA for inviting us to share our best practices. JKPM, as part of JK Paper Limited, we have 3 units, Songad, Raigad, and in Sirpur. We are coming from Raigada unit. Screen is not changing. Okay.
Surya Narayana, we can see the screen. Yeah, please.
Yeah, no, it's okay. To set the context, the sustainability goals are a call for action by all countries to promote prosperity while protecting the planet. Resource efficiency is directly impacting 12 out of 17 goals. Resource efficiency is foundation of sustainable operations at JKPM. We have started our sustainable journey in 1962. In 2013, we had made a major step towards sustainability. As I mentioned, in 2013-14, we have seen a major expansion, and 15-16, where we stabilized our new project, we could improve our production levels by 125%. And in 2019-20, we have seen a very best year in terms of performance or environment management. And 2021, we could see a dip in our production, and this dip is almost to the levels of 15-16 year. So I am comparing these 2 years, how we have performed between these 2 years in terms of resource efficiency. Just I need your focus on this slide. In 2015, I'll take a pointer. Give me a minute. In 2015-16, we have consumed 57% less coal compared to 12-13. This is because of technology. And in water also, we have seen less 44% compared to 12-13. In 2021, where the production levels are almost similar, we have seen 25% further reduction of our coal compared to 15-16 levels, and 28% further reduction of water compared to 15-16 levels. Total, the reduction is 68 and 60%. Our climate change commitment, India has committed to reduce climate emission intensity by 33 to 35% of the level 2005 by 2030. In last 10 years itself, JKPM has cut down its emissions by 60%, despite the fact that we are carbon positive company, and almost we are 3 times more carbon is being sequestered than what we are emitting into the climate. We still have very stringent emission intensity norms at a plant level. We are plant level scope 1 and 2 emissions, we have very stringent targets. Last 5 years, we have reduced 25% emission intensity in scope 1 and 2. This is a small view of our plant, pulp mill running at a capacity of 230,000, and India's most resource efficient paper machine, I must say 190,000 tons per annum. And relay SRS, we have pallet SRS, and we convert 600 tons a day in this plant. And you will see in this area 10 persons per shift. We use robots for palletizing. And a brief introduction of our energy scenario. We have 2 boilers, one CF boiler and one LF boiler. We are operating our LF boiler at 175 TPH, and it caters the steam to 2 turbines, 25 megawatt and 3.4 megawatt, which we installed recently. And the total power that comes out of this is 26 megawatt, which is green energy, and 14 megawatt comes from CF boiler. The renewable energy share is around 63%, and year after year, our CF boiler load is coming down, despite the fact that our production has increased from 2015-16 to 19-20. Coming to the key resources, just like Tapilal was saying, that raw material, additives, assets, and utilities, and human resource. For the sake of convenience, I renamed into different terms. The best practices in raw material, we have done extensive plantation drive within our 200-kilometer range to improve our raw material availability near to our plant. Average truck distance has come down from 700 km to 150 km from 2018-19. We are now procuring only from very near to our plant. This has reduced GHG emissions, scope 3 emissions by 18,000 tons per annum. And compared to 2012-13, now we are using 17% less wood to make 1 ton of paper. And key reasons are reducing our fiber losses, finishing losses, improving our yield. And fiber loss reduction has seen, if you avoid 1 ton of fiber loss, you can avoid 700 kg of CO2 emissions. If you reduce 1 ton of finishing loss, you will avoid 900 kg of CO2 emissions. We have installed new reminders in our all old paper machines. Bleach chemicals. Next resource is chemical. In chemicals, we have seen a drastic reduction in our consumption, like be it lime, be it ClO2, H2O2, caustic. I'm placing a study on ClO2 reduction. We have used machine learning algorithms to reduce our ClO2 consumption. In 2018-19, historian servers were installed, IT/OT platform was provided, and we have used advanced machine learning algorithms with the help of our OEM supplier. We could save 300 kilowatt of power due to CO2 reduction is tuned to the 24%. And next resource is assets. We have improved our assets capacity utilization by means of debottlenecking, continuous improvement through TPM philosophy, and also we have invested in our old machines. In pulp mill and PM6, we have invested a couple of $1 million to improve our performance. Like we have upgraded motors and we have upgraded few pumps. We have invested to actually increase our power consumption. But these investments have brought lot of stability to our plant. And when the plant got stabilized, the process team could focus on improving other consumptions like digested temperature optimization and white liquor GPL improvement or VFD control from valve controlling. These things have brought lot of energy reductions. What I'm trying to say, once the plant, we must focus on plant stability first, then specific energy consumptions will come down automatically. Next focus is on PM6. PM6 also we have invested to improve the plant stability, and it has improved our energy performance by 8 to 7%. This also is, you can see in 2021 we have produced far less compared to 15-16, but still our energy performance has improved. These investments have brought a lot of resilience in the system where we are operating as less production. Also, we could improve our specific energy consumptions. In PM345, we have invested heavily because we have PM6, one side very advanced plant and old machines with old technologies. We could easily fill the gas, and we have invested in silent drive, stationary siphon system in all old machines. 2 machines we have given headworks, and 3 machines we have given CD caliper profilers, and all stock preparations are now with continuous processes, and various pumps line sizes were upgraded. We could witness a production capacity increase by 25%, whereas our it also avoided 7,000 tons of CO2 per annum. Next precious resource is air. The case study that I am trying to present is centralized compressed air system. In after expansion, we were having one compressor house for new plant and one compressor house for old plant. What we have done, 2 rotary compressors were running in old plant. 1 rotary compressor we bought to new plant, and we stopped the entire compressor house of old plant, which saved around 24% of our compressed air power. And we also have one more good practice of air leak audits yearly by external party, and we also do the compliance audit after annual shutdown. Next precious resource, water gets a lot of respect in our plant. The best practices I can share that we have reclamation plants in Sages where the 2 clarifiers collect water from all pepper machines. Pulp mill and pulp mill effluent goes directly to effluent treatment plant, and reclamation plant collects water from pepper machines. The clarified water is used in vacuum pumps, pulpers, and pulp dilution, and also in DD washers, etc. We have done a water pinch study in 2018-19, and our specific water consumption has come down by 29%. Some of the best practices are STP water in our colony, STP plant in our colony. The water is reused back to the tune of 1,000 meter cube a day. And you can see here super calendar hydraulic heat exchanger water. This water we are sending to pepper machine 1 as a fresh water. The complete pepper machine 1 fresh water has been cut. The evaporator seal water collection pit, whatever evaporator plant has the seal water collections, we collect in a seal water, we collect in a pit, and we have installed 2 conductivity meters, and the water is pumped back to cooling tower as a makeup. The point I want to make through this slide is water will save power because it also saves power pumping energy, but water has saved steam for us in several instances. In cost saving plant, we have reduced our steam consumption by 90% or more than that by simply reusing available backwater or the condensate from evaporator. You can see the trends of effluent characteristics per ton of pepper along with water consumption. The effluent characteristics also improved because we have reduced fiber loss, we have reduced chemical usages along with that. Next precious resource is our fuel. Under fuel, in 2018-19, we have gone for micro turbine. Earlier to this, whenever 170 TPH is being produced by LF boiler, we are forced to pass the additional steam through PRDS. To keep the PRDS live, we are supposed to pass some amount of steam all the time. So we have invested in 3.4 megawatt micro turbine, and this has given very good savings to us and very good coal reduction. One more best case study is centralized refiner. In PM 345, we used to have 6 refiners, and all 6 refiners, no load power was very high, 200 kilowatt per refiner. What we have done is we have installed 2 jumbo refiners, and we have stopped all 6 refiners, which saved very good power for us. Methanol plant, which is one of its kind in India, we have started this plant as an environment project. Earlier, stripped off gases from our stripper used to send to lime kiln. Whenever there is a lime kiln breakdown or something comes up, we used to vent these SOG gases, and a lot of smell complaint used to come. We started this as an environment project, expecting payback around 4 years like that, and it has resulted in less than 1 year payback, and it has given a lot of reduction in our furnace oil consumption. One more innovative project from our recovery boiler. Earlier, what used to do, untreated condensate we used to send to recovery boiler through condensate polisher. From last 3 years, what we are doing, untreated condensate from untreated condensate tank, we are directly sending to recovery boiler, bypassing polishing unit. We have installed duplex strainers. We have installed
Mr. Surya.
Yes, sir.
Mr. Surya.
Yes, sir.
Can you? I'm very sorry. It's a very interesting presentation.
I am completing, sir.
Yeah, please.
Thank you. So it saved a good amount of steam for us. And last resource, but very important resource, is our human resource. Without top management support and time, we can't achieve anything what we have achieved in last 5 years. There is a continuous push from top management to reduce our emission intensity. There are various rewards and recognition programs, and we have various awareness sessions. And one point I want to make, one strong pillar for us is quality circles. Wherever which department the quality circle performing well, where we have seen massive reduction in our energy consumptions also. This coating plant I'm sharing is one example, but we have seen in PM6, we have seen in other plants in the plant. What is our way forward? Technology has brought us 54% improvement, and in 5 years, whereas process optimization has brought another 25% improvement. Now we are banking heavily on digital transformation to bring further improvement of 20%, which will drive us in next 3-4 years. We are targeting for 75% renewable energy by 2025, from now 63%. I'm sharing few awards. This IPMA Paper Mill of the Year award, because I am sharing because IPMA is the organizer for this session, and CII has given us Energy Management Award. Our unit head always says resource efficiency addresses economical, social, and environment issues at the same time. Thank you all. Summary is, what's good for the planet is good for our business too. Thank you.
Thank you, Mr. Surya Narayana. Very interesting presentation on your achievements, particularly the reduction you have shown in resources from 68% and 60%. That's remarkable. You are carbon positive company with extensive plantation, almost achieved 18,000 metric ton of CO2 emissions reduction. That's remarkable. The company certainly is very highly placed, and at the last you had shown your future roadmap. That is interesting. After achieving the technology transformation, going for the process optimization, and then for the digital transformation. That's really interesting. I have all the hopes that we'll certainly have a lot of things to learn from you, and this presentation will be an eye-opener for our viewers. Thank you very much.
Thank you, sir. Thanks for the opportunity. Thank you very much.
Thank you, sir. So now I invite Mr. Binoy. He's from Yes Pekka Limited, Energy Conservation Head. So he's going to present the Yes Pekka Limited approach to energy and environment management. Mr. Binoy, please be brief and show your key achievements. Thank you very much now with being with us, and please, the stage is yours now. Please.
Good evening.
Good
I'm
evening,
Binoy
Mr.
Vijayan.
Binoy. Yeah, we cannot see you. Can you please start your video also?
1 second, sir.
Mr. Binoy, is there some problem? Hello?
Yes, I'm trying to start the video.
Yeah, sure. You have some video also. Okay.
Just trying to start it. 1 second, sir. Sir, is the video visible now?
No, it is not visible. Can you?
Sir, is the PPT visible now?
PPT was visible because you can just try again.
Sir, the screen is up, sir, and we can see you also, sir.
Yeah, this is your presentation, no? This is all right.
Sir, should I start with the
Yeah,
presentation?
please start with your presentation.
Fine. Good evening, everyone. I'm Binoy Vijayan, heading papers. I'm making a presentation on our organization's approach to energy and environment management. These are the contents of the presentation. Now, every organization has a vision which it tries to achieve through its activities. This is our vision. We contribute towards a greener planet by developing and promoting compostable packaging solutions we believe in, and this is our strategic goal for the year 2025. These are our core competencies: 100% agro-based plant, focus on renewable and consumed in our plant is being generated through renewable sources of energy. Manufacturing of molded products, we have a flat management system, self-sufficiency in power, which means we are not importing any power from the grid. We are not connected with the grid at all. Whatever power or steam is being consumed in the plant is being generated from two in-house captive power plants. Manufacturing of specialty craft paper. Now, the initiation of a This is our energy policy. Yes Pekka Limited is committed to continually strive for energy conservation in all its activities and products, and also generate power through environmentally sustainable sources. We strive to achieve the above by conducting regular management reviews to ensure continual improvement, controlling energy consumption through daily monitoring and tracking, reducing specific energy audits conducted, procuring energy efficient products, spreading awareness about energy conservation, and motivating teams to get This is our environment policy. Our purpose is to contribute towards a greener planet, which is quite similar to our vision, by developing and promoting compostable packaging solutions through sustainable practices. Our philosophy is to promote sustainable practices as we want to be catalysts for change. Our performance against the plan. Promoting practices consistent with environmental protection both within and outside the premises. Ensuring minimizing the negative impact on environment through process of continuous improvement in environmental performance. Participate in local initiatives to improve the quality of the environment. Commit to monitor energy consumption on a regular basis and seek opportunity to reduce use of material, energy waste, etc. Create awareness campaigns for promoting good environmental practices. Now, what is the role of a management in team engagement? We have a dedicated energy conservation cell known as Team Tejaswar, which is devoted specifically to the purpose of energy conservation. Daily announcement of power, steam, and water consumption data is done in the assembly in the morning. Awards and recognition schemes exist for teams through Kaizen. Competitions are conducted to spread awareness and motivate team members. Regular internal training is given to team members. Regular management reviews are conducted. Periodical energy and water audits are conducted. This is the trend of production over the past few years in the pulp and paper section of our unit. On the left-hand side of your screen, you can see that on an absolute basis, the finished production in the pulp and paper section has been increasing on a year-on-year basis from 2016 to 2019-20. In 2020, unfortunately, due to COVID, we could not meet our production targets. On the right-hand side of your screen, you can see the average monthly production on a yearly basis. The average monthly production has increased in 2016-17 to 2019-20 from 2,878 metric tons per month to 3,412 metric tons per month. In 2020-21, as we were hit by COVID, it went down. Then again this year, since April, it has gone up from 3,501 metric tons per month to 4,121 metric tons. This is the trend of our steam consumption. It was 9.19 in 2017-18. We were able to maintain it up to 9.1, but then again, due to low production, it went up in 2020-21. And we have been on a reducing trend since April 2021. And some more projects are going to be implemented, which will bring it down further. This is a trend of specific power consumption in our unit, which was on a rising trend. This year, after implementation of certain energy conservation projects, we have been able to pull it down further from 1160 to 1002 kilowatts per metric ton. This is the trend of specific water consumption in our unit. It was 62 KL per metric ton in 2017-18 and has come down to almost 52 kiloliters per metric ton in 2020-21. And this year, since April, it has come down even further to 35 KL per metric ton. Now, moving on to the best practices in power and steam consumption reduction. Installation of VFD in different areas has led to a saving of close to 7.5 lakh kilowatt hours. Installation of energy efficient equipments by replacing old ones has led to an energy saving of close to 6.41 kilowatt hours. Thermal energy to the tune of 50,100 kilocalories has been saved by implementing certain heat energy saving projects in pulp mill and recovery. Some other automation projects in different areas of the plant have led to a saving of close to 1.13 lakh kilowatt hours. These are some of the details of the projects that we have implemented. Installation of VFD and deaerator transfer feed pump, installation of VFD on boiler feed pumps, replacing old inefficient compressors with VFD run compressors in power plant 1, stoppage of an 11 kilowatt compressor in X-ray by modification of compressed air lines, implementation of a white liquor heating project has led to thermal energy saving to the tune of 41,000 kilocalories per day. Replacement of inefficient soot blowers and recovery boiler has led to a thermal energy saving of 8,400 kilocalories per day. Replacement of metallic blades of cooling tower fan with FRP blades has led to a saving of 55,000 kilowatt hours per year. Inefficient vacuum pumps in PM2 were replaced with energy efficient vacuum pumps, which has led to a power saving to the tune of 2.49 lakh kilowatt hours per year. Installation of VFD, cooling water pumps, and boiler feed pumps has led to savings to the tune of 70,000, 53,000, 25,000 kilowatt hours per year. Installation of VFD in BSW3 has led to a saving of 1.04 kilowatt hours, lakh kilowatt hours per year. Automation in UTM pulper has led to a saving of 1.93 lakh kilowatt hours per year. These are some of the upcoming projects. Bulk motor replacement, replacing old inefficient motors with energy efficient IE3 motors. Automation of MPS feed pump through VFD. Digester CBD cooling project, which is a steam saving project, thermal energy saving project. Separate superheater pumps are going to be installed in power plant 2 to bring down the power consumption in our boiler feed pump. Installation of FRP blades in remaining areas of the plant. Installation of air filters to bring down the compressed air leakages in our tableware unit. Installation of double orifice steam traps for empty heaters in paper machine. Now, some of our best practices in water conservation. Why should we save water? You are 60% water, so save 60% of yourself. This is the distribution of water consumption in different areas of our plant. These are some of the projects which we have undertaken under the concept of reduce, reuse, and recycle. To start off with reuse, we have installed MPS in paper machine 2, paper machine 3, and mold machines. We have installed Sedicel in paper machine 1, which have yielded to water saving to the tune of 140, 130, 400 meter cubes per day. All pumps sealing water have been recovered by installation of pit and pump at pulp mill. Replacement of evaporator PHE with new PHE has enhanced 20% extra generation of foul condensate, which is being used for brown stock washing. Installation of effective high pressure shower for pickup felt cleaning with lower number of nozzles and lesser nozzle size at paper machine 3 has yielded to a saving of 25 meter cubes per day. Under recycle, we have recycled ETP treated water in different areas. We have used them in different areas of the plant, like for ash quenching and wet scrubbing at boiler feed pump 4, for extraction stage washing in bleach plant, in 4th stage washers repulper at pulp mill.
Mr. Binoy,
Yes,
please.
sir.
Yeah, please. We are running short of time, please.
Yes, I'll finish it real soon. These are some of our best practices in environment. Keeping up with the vision, we have commissioned a tableware unit, a molded products unit in 2017, which the products of which can be used as a replacement to one-time plastic like paper plates, bowls, containers, lids. This plant has a capacity of 12.5 metric tons per day. We have also commissioned an X-ray unit which is being used for replacement of plastic X-rays. Both these plants have been running since 2016 and 17. These are some of the best practices which we have been practicing in environment management, installation of scrubber units in power plants, TFH, replacement of old ESPs to meet the norms and benchmarks of the industry. Wet washing unit was installed in pulp mill. Dust control was done in repeating units. New soft spray showers were installed in BSW. Bad consistency optimization was done. Some automation projects were also done in pulp mill to reduce soda losses. Seal tank level control loop was given. Washing feed flow control was given. Washers RPM was controlled in auto. And one of the upcoming projects which is still in talks is TCF bleaching project for pulp mill. And on this note, I'll thank you for your time and giving us this opportunity to present our best practices in energy and environment management. Thank you.
Thank you, Mr. Binoy. Very good presentation. Always I am delighted with the work being done at Yashpak. You have a great management and have been doing a lot of work, particularly Kaizen and energy management activities. Best practices in the environment area are really remarkable. Thank you very much. Thank you.
Thanks.
Thank you very much. So now I invite Mr. Ashwini Kumar. He is the Manager Manufacturing Excellence in Andhra Pradesh Paper Mills. And Mr. Ashwini Kumar will be talking about manufacturing excellence, a systematic way to compete the world. My video is not getting started. It's all right. It's all right. Now it is there. It's all right. So, Mr. Ashwini, please.
Okay. Thank you, Taplial sir. So I'll just share presentation.
Just 1 minute, Mr. Ashwini. Do we have the presenter from TNPL also with us? From CIA, Mr. Ashwini.
Yeah, sir, he is just joining in.
Okay. That's right.
Sir, just before Ashwini sir starts his presentation, just an announcement. The participants who are seeing it on Hive, if they have any questions, they can post it in the Q&A box that is there on Hive, so that we can take up those questions at the end. Thank you.
Very sorry, I could not announce that. Yeah, thank you. Thank you.
Okay, good afternoon all. Myself Ashwini Kumar. I'm looking after manufacturing excellence in Andhra Paper Limited. I'm going to share one of the best practice which we follow in Andhra Paper Limited. It's a manufacturing excellence. So content, I'll start with the introduction of my organization, then history of manufacturing excellence, then some of the philosophy and tools and methodology of manufacturing excellence and how we have implemented in Andhra Paper Limited, and what are the benefits and some of the examples from ME. So about my organization, I think this is the one of the oldest establishment in paper industry. It was established in 1921. So we have completed 100 years this now. And after that, it named was Carnatic Paper Mill Limited. After that, Andhra government took over it. Then APPM became a joint venture and named Andhra Pradesh Paper Mill. And in 2000, we have to acquire Coastal Paper Mill. So now it's a Kadiam unit of our plant. So in 2011, International Paper collaborated with the APPM. Then it became International Paper APPM Limited. In 2019, SK Bangar Group has took over, and now it's named Andhra Paper Limited. So we are an ISO certified company and FSC certified company and publicly traded in BSE and NSE. So at Andhra Paper Limited, we manufacture a wide range of paper, mainly copier. We have main brand Reflection, which we have several variety in Reflection. Apart from that, we manufacture Andhra Premium Paper and Super Print. And we manufacture HP paper also. We are the only company in India which make HP paper with Karalok technology. And apart from copier, we manufacture other products also: Maplitho, Creambo, thermal paper, cup stock, and other. So I'll start how the ME concept started, sir. In earlier days, in industry, when industries were less and the consumer were not much focused on quality, so whatever this quality was manufactured, customer were accepting that. So our focus was how we can supply much to the market and at a lower cost. But as the market grown and the competition has increased, so now the consumer is asking quality more. And whatever the speed or cost, they don't bother about that. Whatever the market cost is there, they will buy at that, sir. So now to make profitability, we have not much options. So one option, either we make a higher quality with a consistent quality, or reduce the wastage in the system, sir. So the ME concept has evolved in that. It started from just root cause analysis to then some statistical tools, then quality management, then Lean and Six Sigma concept came. But even after that, it was just for in localized or in some function it was applicable. So the concept of enterprise-wise excellence came in picture. So whenever see in our improvement opportunities, we will find 4 type of improvement opportunities. There will be some like fallen fruits which are available in the floor, and we have to just grab it by just simple logics and intuitions. And the next category is hanging fruit, which we can capture by using simple QC tools. Then comes the bulk of fruits, which can be captured by the process characterization and optimization. But the sweetest fruit will be at the top, which requires focused effort and skill, and the tools and the techniques it's required to capture those sweetest fruits. So in traditional approach, we see that we work on many problems at a time, but we compromise in the analysis, because we cannot work on all projects at a time. So we work on the surface only. So we get a solution with that by opinion based solutions, which can be wrong sometime, or sometime it can be right also. But in deliberate improvement approach, we select few projects only, and we go into the deep of the root analysis. So the probability of getting sustainable solution is higher, sir, in this case. So manufacturing excellence at Andhra Paper means maximizing the rate of improvement by prioritizing all the right things and using all resources to achieve sustainable results, sir. There are three components of manufacturing excellence at APL. The strategic deployment, which helps to align the all action to the goals. Then capability building, which includes trainings and engagement of all employees for improvement. Then third part is predictable methods, the tools and methodologies. In APL we use Lean and Six Sigma, and PDCA is our core principle. So vision of ME is to build a predictable improvement capability, include all employees, bring a culture. Every project should be attached to the financial saving. And in short, we can say that everybody should be involved in improvement culture, sir. So if we talk about ME mechanism, so we say if we can bring the knowledge and skill of the people on technical side and methods and tools of the Lean Six Sigma, and if we can create a mindset of the people, if we bring all together into action, so we can achieve sustainable results. So whenever we work in the floors, we found many opportunities, many ideas, but we cannot work on every idea because of the limited resources. So ME allow us to prioritize the projects which are aligned to the organization goal and work on it to the depth of its root and solve it and get the sustainable results. So one component of ME is strategic deployment, which says that how we can bring down the goals and objective into the action at the floor level, and how the feedback can go back to the organizational level, sir. And then another part, the capability building. So at APL, we have five level belt structure, which start from master black belt, who is a subject matter expert in tools and methodology, who owns the training. Then black belt, who has knowledge of Lean Six Sigma, and coach and mentor for green belts. Then green belts, who are good in DMAC approach, and they take critical improvement resources. Then yellow belt, they're expert in lean concept, the lead high important lean project. And next category is white belt. White belt is, they should have basic knowledge of ME and they take part in all improvement. So at Andhra Paper, around 90% of our all employees are trained in ME concepts. So we use two main methods, Six Sigma and Lean. Six Sigma to reduce wherever we find variation, we use Six Sigma tools. Those are mainly statistical tools like process capability, NOR, correlation regression, chi-square test, control charts, etc. And in Lean, it's to reduce waste. So we use tools like VSM, 5S, push, pull, SPAD, Kaizen, FMEA, YY, others. So in Six Sigma, we use a DMAIC approach, sir. So where we define the problem, measure where we are, and analyze the data, why the problem is, then try to find a solution and implement it then make a control system so that we can get a sustainable result. So in a simple term, we can say that convert practical problem into statistical problem, then find a statistical solution, then convert statistical solution into practical solution. And PDCA is the core concept of this. So plan, do, check, adjust. So in lean concept, we use some specific tools to improve continuously so that we can reduce waste in the system and make system faster, and there is no waste in the system. So there are eight type of waste in the system, from defects, overproduction, waiting, non-utilized talent, transportation, inventory, motion, extra motion. To remember this, we can say it's a downtime. So at APL, how we have implemented, we initiated this ME function in 2013, and that initially the 2013 year was for planning only. So in 2014, we officially kicked off the first batch of our green belt, black belt. Then we started taking projects in different areas. So in 2015, we accelerated it. We have taken another batch of green belt, black belt, and we trained in ME for all staff, minimum training for all staff. Then from 2016, we started institutionalization of the ME concept. We started training of all employees, including workmen. So now around 90% of our permanent employees are trained in.
Mr. Ashwini, Mr.
Yes,
Ashwini,
sir.
please,
Sir.
can you
Yes,
little
I'll
bit be
just,
faster?
I'll
Yeah,
just,
please.
So there are some process we use. This is the organization structure we have. So it starts from ME and GMS Council. Mill managers are the owner of the system. Manager manufacturing excellence is responsible for execution part. To help MME, there is a ME steering team which consists with all functional leaders. So this is the one cost reduction roadmap, sir. We get priorities from top management. We have a set target of 3% YOY improvement and a 5-year organization strategy. So we have one more tool we use, realizer R-gap, which help us to how far from the benchmark we are. Then another tool we use, cost reduction project identification. We collect projects from all employees. Then we put it into strategic deployment. From there, we prioritize the key projects. Then we divide into this prioritized project into two parts. One is a DI project, another one is a non-DI project. Non-DI project, we just give it to capital team so that they can execute it. And deliberate improvement project, we assign it to the trained belt and they execute the project, sir. So the ME is nothing but it's a team effort, sir. So it involves from leadership to the execution team levels. So our role on ME is to set objective, use tool to achieve, engage the entire team, and ensure shared responsibility. Be a catalyst and try to replicate the best practices. So by this, we can achieve variation reduction, defect reduction, yield improvement. In short, we can say that you improve the bottom line. So in last from 2014 onward, we have taken around 1250 improvement projects till date, sir. So every year now we are at a sustained level. So we take around 300 projects every year. So the saving achieved from in last 7 years, sir, it's around 130 crore incremental savings. So around 30 crore we achieve every year, sir. So on variable cost part, we reduced variable cost by 13% from 2015, including the purchase price variation, because everything rate of everything has increased. So including that, we have reduced our variable cost by 13%. So these are some example of the improvement, how we track in the Minitab software statistical tools. So this is the improvement trend of Rajmundry, sir. The pulp production increased by around 10%, pulp yield improved by 1.5%, and chemical consumption has reduced by 10%. Paper production increased by 8%, finishing loss reduced by 2%, and all the rate of production increased by around 5%. Ash improved around 1%. The pulp to paper ratio has reduced by around 6%. Water consumption reduced by around 20%. Steam consumption reduced by 10%. Coal consumption has reduced around 20%. Then the power consumption had reduced by 20%. So in Kadiam also the same trend. Pulp production increased, yield improved by 6%. Finished production improved by around 20%. Finishing loss reduced by 0.5%. Overall ash improved by 1%. Water consumption reduced around 30%. Steam consumption reduced by around 15%. Coal consumption reduced around 10 to 15%. Power consumption reduced by 12 to 13%. So, if we say that what are the takeaway of this presentation, one is the manufacturing excellence. It means to maximize the rate of improvement by focusing on and prioritizing the right things and using all resources to achieve them. The deliberate improvement, that improvements are which needs extra effort to accomplish. PDCA, this is our core principle: plan, do, check, adjust. Strategic deployment, to align our action with our organization goal. And the most important part, project process owner and champions of the projects have key role in the ME program. So thank you. This is end of my presentation. So any question? I think question answer will be at the end of session. So,
yeah, thank you,
sir.
Mr. Ashwini. Thank you very much. We'll take up the questions and your answers at the end of the session. We were just thinking that to bring in, but since now we have with us the speakers from TNPL, we would like to go ahead. But I must congratulate you, Mr. Ashwini, on being a 100-year-old company in the business, and on your excellent presentation about ME concept from concept to its application at the enterprise level, and the remarkable achievements you have shown. It will set an example for our paper industry to lead this type of examples in their units also. Thank you very much. The takeaway is very nice with you. Thank you.
Thank you, sir.
So, Mr. Ashwin, we are now planning, because we have the speakers from TNPL with us. So we are planning to go ahead with our presentation, and at the end of this presentation, we will take the questions and answers.
Sure.
Sure. So, Mr. I welcome our colleagues from TNPL, Dr. Sudarshan and Dr. Ashokan. I think who is presenting, I don't know, Dr. Sudarshan or Dr. Ashokan, but they are going to speak on a systematic approach to reduce the ring formation in the lime kiln, and they are going to make a case study also. But Mr. Ashokan, I'll request you to be very brief because we are already late, delayed by almost some 10-15 minutes. So please try to finish it within 10 minutes, please. Please start, please.
Sir, good evening, sir. Sir, can you hear me?
Yes, yes, we can hear you. Please continue.
Yes, sir. Now you go to the full slide mode. Good evening, sir. On the behalf of TNPL, I am Dr. K. Sudarshan, Assistant Manager R&D, and my colleague Dr. S. Asogan, Senior Manager Soda Recovery Plant Mechanical. We both gave the presentation about the systematic approach to the ring formation in integrated pulp and paper industry. So it is a TNPL case study. So everybody knows about the TNPL is environment loving unit. At the same time, everybody knows, all pulp and paper professional well know about this pulp mill soda recovery closed loop process. So within the closed loop process, the importance of lime kiln in pulp and paper industry. What does lime kiln do in a paper mill? A lime kiln is used to convert lime mud into lime for reuse in the processing plant of the craft recovery process for the production of cooking liquor. So why it is important? It is a closed loop chemical recovery process in an integrated pulp and paper industries to produce cooking liquor from solid waste, that is lime mud. The cooking liquor preparation depends on the burnt lime availability, and thereby it influences the production of the pulp. Ultimately, it is impacted on the paper production. If reburnt lime is not available, purchased lime has to be used for producing cooking liquor, but this will increase the cost of the production. Hence, the lime kiln operation is one of the determining factors for overall production cost in an integrated pulp and paper industry. So in TNPL, we are having two number of lime kilns. In each having capacity is 170 tons per day. Lime kiln 1 size is 82 meter long and 3.2 meter dia, and whereas lime kiln 2 85 meter long and 3.2 meter dia. It is lime kiln 1 is single layer brick lining and lime kiln 2 is double layer brick lining. 60 lakh thousand of m³ of biogas is used as auxiliary fuel to replace 3,600 metric ton of furnace oil per annum in lime kiln. So lime kiln process steps: drying the lime mud and heating the lime mud and calcination of calcium carbonate and sintering of the lime. So common problem that occur in an integrated pulp and paper industry is lime kiln mud ring formation. How to overcome? A systematic approach to the kiln operation with respect to chemistry and engineering. So it's a case study. On November 2017, lime kiln 1 was stopped due to the ring formation, and subsequently the same was happened on 15th February 2018. But the ring formation has not happened in the lime kiln 2. Thus, R&D and SRP team analyzed to explore the causes of this frequent ring formation in lime kiln 1. This is the ring formed in lime kiln 1. So what to be done? Simple. Analyze ring sample and operational data. So most influencing parameters for ring formation is speed, throughput, high alkali content in lime mud, temperature profile variation, adequate excess oxygen. So while analyze the feed throughput, when took the shift-wise trend analysis, we cannot able to see the stoppage, but we can run the trend with a fixed interval at 1 minute interval. At that time only we found this frequent stoppage and startup. During this limestone feed speed trend, it was observed that the stone feed was stopped 3 times within 4 hours. So normally in TNPL lime kiln, the sludge feeding rate 10 tons per hour and stone feeding rate is 5 tons per hour is ordered for calcination. Whenever this type of stoppage is happened, only sludge is entered alone in the kiln with higher heat value for calcination. At this situation, the temperature in the kiln atmosphere has been increased, and thereby alkalis in lime mud melts into liquids as the mud approaches the calcination temperature. If it is occurred routinely,
your voice is not. We are not able to.
Sir,
get your voice. Mr. Kumaraswamy.
Yeah, sir. Audio.
Yeah, please.
Yes. So if it is occurred routinely, the ring is slowly grown in lime kiln. So alkalis in mud melting at high temperature. When analyze the ring sample, it indicates that the total CO is 56.8% and the available CO is 7.6%. This may be due to the higher draft of the ID fan and thereby increases the oxygen content within the lime kiln. Then the temperature profile is shifted from front end to back end of the lime kiln because the higher ID draft. Because of the higher ID draft. In this stage, the alkalis like sodium and potassium in lime mud formed as liquid as the mud approaches the calcination temperature. So at calcination temperature, the formation of alkali liquids on the surface of the mud particles in combination with the rolling action of the bed caused them to agglomerate into the nodules and stick to the wall, forming a ring. And oxygen concentration in flue gas in lime kiln 1. The normal target value for the excess oxygen in the kiln outlet is in the range of 2 to 3% only. But here from the December 2017 onwards, the oxygen concentration has varied up to 5%. This is due to the ID draft varies and within the lime kiln. During this condition, the flame temperature was decreased and thereby burning zone temperature has dropped and shifting of temperature profile in lime kiln. When temperature profile shifts, lime mud approached to the higher temperature and formed a mid-kiln ring. Then the recarbonation. Initially, the ring is very soft and contained both CaCO3 and CaO, calcium oxide. So after some times, the ring thickened whenever operating conditions are changed. The recarbonation reaction occurred, that is, the calcium oxide reacts with carbon dioxide to form calcium carbonate. Again, it converts to limestone, just like limestone. It evidenced that the ring sample analysis of loss on ignition is around 26% in ring sample. Furthermore, the recarbonation was strongly confirmed with the flue gas analysis. This is the carbon dioxide concentration in flue gas is normally 16 to 17% in the range in lime kiln. But during January 2018, the carbon dioxide concentration is 10% only. Hence, the recarbonation results in sintering, which is forming a bridge between lime particles, that is, increased the compressive strength of the ring deposit. So, sulfation. Fuels like furnace oil and NCG releases sulfur content in the firing zone, which first combined with sodium to form sodium sulfate. This was confirmed with the ring analysis. The sulfate content is around 5.6%. Since the concentration of excess oxygen in the kiln and the kiln temperature at the front end is much higher than 1000 degrees Celsius. In this case, the hydrogen sulfide is oxidized rapidly to sulfur dioxide. Depending on the temperature and oxygen level, a small fraction of sulfur dioxide may be oxidized to sulfur trioxide. Here, there is a possibility of excess amount of free SO3, that sulfur trioxide, circulating in the kiln. At a certain concentration level in the kiln flue gas, the sulfation of the free lime occurred with the anhydrous formation of calcium sulfate. So these are the methodology adopted to avoid ring formation. Sorry.
Good evening, Ashokan. The methodology mainly we adopted is for controlling the feed throughput in the lime kiln. We control limestone and lime slates. For uniform flow of limestone, we modified the limestone chute for without choking, we made the limestone without choking by rearranging the configuration as well as the material of construction also we changed to SS. One more thing, we provide one vibrator in the limestone chute for uniform flow of the limestone. For lime slides, we have 2 pre-coat lime mud filters. In the 2 pre-coat lime mud filters, the washing schedule was uniformly scheduled. So in such a way that when one filter is in service, another filter only will be taken for washing. In the same time, the running filters throughput will be increased to match with the uniform throughput to the kiln. Then for mud washing, we are good mud washing we made by pumping the underflow correctly and controlling the alkali loss. By that, we can reduce the sodium compound in the mud, and that will reduce the vaporization and condensation loop in the sodium. Then excess oxygen content in the lime flue gas is controlled by effectively controlling the ID fan. Then for adjust the airflow minimize the temperature variation inside the lime kiln, we control the primary air axial and radial layers by controlling the flame pattern. Then finally, for furnace oil temperature, we maintain at 120 degree for effective combustion. Conclusion. For now, both our kilns are running without non-reacting state and thereby avoiding unplanned shutdowns. Periodically doing systematic calibration of the limestone and limestone feed conveyors for uniform lime feed. Effective alkali washing ensure lower alkali in the mud. Flame length is closely monitored since the biogas is fired along with furnace oil. Thank you.
Thanking you, sir.
Thank you, Dr. Ashokan and Dr. Sudarshan. It was really a very good example of chemistry and engineering aspects of the lime kiln, how to address the problem of ring formation. Very common problem which we face in our operations. And you have shown a very good way, a very nice way, how we can do with the proper analysis and the analysis of the chemistry aspects, how we can address it through following some very simple engineering details like rerouting of the process. So that's very important, and I'm very thankful to you for making this study, because this is really a big problem and downtime is very high in most of the cases. So with this, we are now open for the question and answer session. And prior to that, I'll just like to sum up. We had 4 presentations from the leading mills in our country, and I really thank you for bringing out the real sustainability concept to our viewers and all our attendees. So the first lecture was on best practices on resource efficiency from JK Paper Mill, very nicely presented on how we can contribute towards the resource efficiency. Then Yash Pakka Limited also made a very nice presentation on its approach for energy and environment management with the diversification into different products, particularly taking it to the molded products. And the very nicely presented manufacturing excellence by Mr. Ashwini Kumar, thought-provoking for me, in fact. And I understand that this type of manufacturing excellence should be a part of our manufacturing practices. And I really appreciate it. And then from our friends from TNPL, they made a very good study for everybody to understand that how simply the problems can be addressed, even not only in lime kiln, but many other parts. Lime kiln is a very tedious area where the high temperature and all those things, they make it very difficult to get the proper operations. So this type of dissemination of information by the mills on best operating practices is one of the most accessible way to learn about the best practices being followed by some leading mills. And this paves a way for us to understand how our mills, other mills can follow the example. And the conferences like PaperTech is one of the most feasible way to understand how new technologies and practices being used by other mills in the country can be adopted. The experiences which we have seen here from the leading mills and their technical personnels, it will create confidence among the other mills also to adopt and go for similar sustainability solutions. So with this, I open the floor for question and answer. Mr. Ashwin, can you?
Sir, we don't have any questions from the participants, sir. If they have any queries, they may even email it to us also so that we can reply to them if they have any queries. But as of now, we have not received any questions, sir.
Okay, that's so good, so good. In fact, then we are coming very close to the time when we should close it. And shall I say thanks to all the presenters, or from CII side you are going to speak, Mr. Ashwin?
Sir, you can thank him, sir.
Thank you, Ashwin.
It's okay, sir. Yeah.
So I thank again the speakers from JK Paper Mill, from Yash Pekka, from Andhra Paper Mill now, Andhra Pradesh Mill, and from TNPL for your contribution in this session. It was the last session, I hope, but very interesting session and very important session on the best operating practices in pulp and paper mills. The takeaway will be certainly very much. And again, if you have anyway, you have given a lot of contribution for the industry's best practices dissemination. So I cannot ask you for anything more, but this type of contributions will certainly lead to the industry's upliftment and our technology development, technology adoption. Thank you very much to all of you. And I say goodbye from the side of CII and IRPMA, IPMA, INMA. Thank you very much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.